Hey, it's Fletch, Vice President of Public Safety at 911 Inform. Welcome to the audio version of my latest blog, The Ultimate Adoption of NextGen 911. For at least the last decade, we've been discussing NextGen 911, the services and additional value that they bring, along with the increase in the number of data points that they'll carry. Now, despite this fundamental value, the uptake has still been a little less than inspiring. But while there may exist several root causes for the delays, they're far from being unknown or misunderstood, as is often common with new technology and deployments. A lot of times the initial reaction to any new technology is the perceived cost. We've grown up understanding that if it's new, it's likely to be more expensive than what we've seen in its past, as it carries new and additional capabilities. Now, while some truth may exist to that statement, for things that are physical in nature, often it's untrue for those things that are software-based, or at least automated on a computer platform. Especially ones that involves networks of computers, once reserved for only high-end mathematical and scientific calculations. The evolution of the internet as it exists today has revolutionized everything from banking to e-commerce and the online availability of information and resources to accomplish nearly anything. Actually, this has a tendency to force new innovation within various different processes and ultimately reduce the number of people hours required to accomplish a task. The savings that are associated with those efficiencies get passed directly to the consumer through a lower cost of service, or in many cases, additional value added for the same cost. Either way, a win-win. Now, there's no denying that the legacy 911 network is more than a half a century old, and during its initial development, landline communications were all analog. Even the core backbone of the public switch telephone network operated with very simplistic controls that were all delivered over point-to-point connections. Digital signaling, let alone digital switching, simply didn't exist, and the infrastructure that was required to connect and route calls from coast to coast could easily be conceived as a bit of a science project. As new networks were built and the old networks were updated, digital signaling and transport slowly burgeoned through the core of that network, all the while becoming more robust and informative. Now, IP capabilities allow intelligent point-to-point connections to exist and important data to be communicated from end to end. From an architecture perspective, the need for dedicated point-to-point connections has all but been eliminated, the last bastion being the data security of those networks. So, the question has to be asked, have we finally reached that tipping point, albeit a decade later than anticipated? Based on what's happened over the past year, I think that we have. One of the key indicators of that is the realization of the financial burden that the legacy network is placing on the various players that are involved, forcing them to keep that existing network operational and functioning. The continuous cost of the maintenance and the support of the legacy analog circuits that are in use today is something that the local exchange carriers are really struggling with. Their complete financial model has been exasperated and significantly trimmed, primarily with the eradication of coin payphones. Why? Because of the revenue that they generated. On top of that is the removal of most local toll charges and the expansion of the free calling areas and inexpensive long distance. Because these revenue streams have all but dried up, and the unfortunate timing that they faced with an infrastructure replacement event that's forcing billions of dollars in legacy core infrastructure to be scheduled for the scrapyard and write-off. The scheduled replacement with new server infrastructure and what was called the long lines network needing to be replaced with the internet, as well as associated routers, firewalls, and other network elements required to deliver that new IP backbone. Even at the most recent public safety conferences, although virtual, provided exceptional insight to the current state of affairs in the industry. In addition to the normal technology-focused sessions, there were several case studies presented by those that have taken significant steps at the deployment of infrastructure to support the building of next-generation 911 networks. For instance, the state of California has already made significant efforts in building a statewide emergency services IP network, known as an EZNet. which ultimately will improve interoperability and connectivity across the entire state. As these new pockets of Next-Gen 911 capable infrastructure start coming online, they'll provide a new level of connectivity to PSAPs from the various carrier networks and originating service providers, or OSPs. But in addition to these networks, the enterprise space, which contains a treasure trove of valuable information that could be applicable in the event of an emergency. In addition to providing valuable location data for any incidents originating within their facilities, the data collection from IoT sensors that exist on the property is going to be able to provide relevant and actionable information regarding events that have occurred adjacent to the property, but in view of their sensors. For example, imagine a traffic accident occurs at a busy intersection downtown in the city. It's very likely that IP-enabled video cameras from the local businesses on the corners will cover that entire intersection from 4 separate angles. So in the event of an emergency, crowdsourcing that information could prove to be invaluable. Now, of course, information will only be shared in the event that an incident or event triggered the appropriate logic that allowed the access. So with the availability of data collection in the originating service provider networks, the ability to pass the data through an emergency services IP network and get it into the hands of public safety now exists in a growing number of areas. The next step is to categorize and score that appropriate data, establishing a level of relevancy. So let's take a look on how this capability could easily exist within an enterprise network today. The processes can be as simple as follows. Let's assume that an enterprise has the following points of data available with varying degrees of accuracy. The building, the Avaya LDS application that provides the XY coordinate information, the IP subnet of the device, and the switch port information. Now, some of that information, like the building, is very accurate. And other points, like the switch port, may not be accurate at all or may be missing altogether. For this exercise, we'll assign the values of the different data points as follows. Buildings are worth 4 points. LDS is worth 3. Subnet information is worth 2. And port numbers on the switch ports are worth 1. Then against those data values, we apply an accuracy factor based on our knowledge of the accuracy of each individual data point for our particular areas. For example, we know the building data is always correct, so that gets 100% accuracy. As for the Avaya LDS platform, while the latitude and longitude information, or the XY info, that we collect from the cellular device is very accurate, the problem is that not all cell phone devices contribute a Z, or altitude, yet. So there may be a question as to which floor a device is actually on. Because of that uncertainty, we're going to devalue that information by 10%. So we're only going to use 90% as a maximum. Now, our subnet information is mostly accurate, but we do have a few cables that extend outside the normal physical boundaries. So we're going to devalue that, in this case, by 20%. And as for data switch port information, well, we know the cables are moved in the IDF on a regular basis and rarely get documented. But they do sometimes, so because of that, in this particular building, we're going to discount their value by 40%. Now remember, all of this is just an estimation and a mathematical way of looking at real-world information that we collect about the networks. If need be, some areas can be discounted further than others. In areas where the data is particularly accurate, minimal discounting can be applied. So using this very simple and basic algorithm, we can say that a perfect score is 10 if the max value is achieved for each indicator, and if none of the indicators are discounted. Based on this formula, you can see that consolidating all of the information that's known about a particular device is actually going to provide an 8.9 out of 10 rating based on that particular location information. That tells us even with perfect scores, whatever information we come up with is going to be statistically correct by a factor of 89%. Now, staying true to this model will allow enterprises to establish minimums for particular areas and then plan remediation accordingly, where the impact provides the biggest value. Once again, there's no secret sauce here. We're not collecting any more data than we can collect today. We're just looking at that data in a new and informative way. And we're applying a little bit of statistical evaluation of the level of accuracy that we believe that we're achieving. So what's the impact this can have on an emergency response? Well, if we know we're going to a particular building, but the data shows that there's a possibility of it being 2 different floors for that particular event, we can double up on the response teams, checking both areas simultaneously. That allows us to get help where it's needed as fast as possible and adjust the level of response accordingly when the network teams go through and identify the trouble spots and plan the most appropriate remediation strategies. That wraps up this audio version of my latest blog, Next Generation 911 and its Ultimate Adoption. I'm Mark Fletcher. I'm the Vice President of Public Safety Solutions at 911 Inform. Be sure to follow me on Twitter at Fletch911. You can also check out the rest of my blogs and podcasts at Fletch.tv. Be sure to like and subscribe. That way you'll be immediately notified whenever a new podcast or blog is published. Take care and stay safe.